Okay, this is Dr. Williamson. I'm going to go over the heat capacity lab for the for Chem 1A. And I'm making up, these are sample pretend numbers just to do sample calculations. I'm not saying these are the numbers that you will get. I'm not even saying these numbers are going to totally make sense because I'm making them up on the fly. But let's say I have a piece of metal that I have heated up to, let's say, 95 degrees Celsius right here. And then I drop it into the water right here. And let's say this piece of metal weighs 15 grams of metal. So mass of the metal is, let's say, 15 grams. We're just going to have to remember that. And it's initially at 95 degrees Celsius when I drop it into this water. The water, initial temperature of the water is 20 degrees Celsius. And let's say the mass of the water, let's turn that into blue. The mass of the water is, let's say, 30 grams of water. You'll have different numbers of sig figs because you guys have a different scale. 30 grams of water. When I drop the metal into this water, the heat is going to flow from the metal into the water until the metal cools off and the water warms up and the temperature of the metal becomes the same temperature as the temperature of the water. So the heat from the metal will leave and go into the water. Okay? So I measure the temperature of the water. And let's say the temperature of the water, which was initially at 20 degrees Celsius, it rises and it goes up to, let's say, 30 degrees Celsius. Making up numbers here, guys. 30 degrees C. Okay. So the heat that the water absorbed will be equal to, let's do this, I'll do it, I'll type it, it'll be faster. The heat that the water absorbed from the metal will be equal to the mass of the water, 30 grams, times the heat capacity, 4.184 joules per gram per degree C, times the temperature change, which is 30 degrees C minus 20 degrees C. And I get my calculator out. Hey guys, so 30 minus 20 is going to be 10 times 4.184 times 30. And I'm going to get here 1260 joules when I do basically the correct number of sig figs. That's the amount of heat that the water absorbed. That means that, I'm going to change it here. The amount of heat that the metal released is the mass of the metal times the heat capacity of the metal times the final temperature minus the equilibrium excuse me, the equilibrium temperature minus the initial temperature of the metal, right? That will be equal to 1260 joules. Okay, now I got that minus sign there. What do I do with that? Well, let's take a look here. What was the mass of my metal? The mass of my metal was 15 grams. The heat capacity of my metal is what I'm solving for. I'm supposed to use an asterisk. The equilibrium temperature is 30 degrees Celsius minus my initial temperature, which was, what was my 95 degrees Celsius. See, that's going to give me a negative value, equals 1260 joules. $30 minus 95 is going to give me a minus sign. Fortunately, I have this extra minus sign that is put in over here. Do you guys see that? That's why we put the minus sign over here in front of Q metal, because it's heat leaving. So when I rearrange my math, let's do this. I'm going to have the heat capacity of my metal. Heat capacity of the metal is going to be 1260 joules over negative 15 grams. And that minus sign can be on the top or the bottom, it doesn't matter. And here I'm going to have 30 Celsius minus 95 Celsius. Right, I'll put my Celsius outside. Right, why is it 30 minus 95? Because it's final temperature or equilibrium temperature minus the initial temperature. The initial temperature, the metal, remember, you heated it up before you dropped it in. So it started at 95. The initial temperature was high, and then it cooled off. So the initial temperature was 95. The final temperature, the equilibrium temperature, was, in my pretend example, 30. So this 30 minus 95 is a negative value. Then I got another negative sign. So when I do this, 1260 divided by 15 divided by 30 minus 95, I get, in my pretend example, 1.29 joules per gram per degree Celsius. And that would be the heat capacity for my pretend metal that I'm using in my example here. And then I would go look for, in my lab, what metal had a heat capacity of 1.29 joules per gram per degree Celsius. That's how that works. Okay, so I hope this helps, and I'll do some more problems later. Okay, then.